you see the slide now? Okay, perfect. Thank you so much. So these are the materials for the Jupyter book and the GitHub repository for this tutorial. So since we're short on time, I'll get started. The first part of this tutorial is going to cover an introduction to Xarray and the fundamentals of Xarray and how we can use Xarray to do different types of data analysis. And then the second part of it is going to be more focused on using Dask to speed up the analysis. So let's get started. I'm sure most of you are familiar with Xarray. So Xarray is an open source Python library that makes working with multidimensional and labeled dataset very easy. And when we say multidimensional, we mean that it has many different independent dimensions. And by label, we mean that it has like some coordinate values attached to it. For example, the latitude and longitude. So Xarray has two different fundamental data structures, a data array and a data set. A data array is some data, for example, a variable, and a lot of metadata attached to it. So for the four main attributes of it is the underlying data, the dimensions of the data, the coordinates, variables of the data, and any arbitrary attributes. For example, the metadata attached to the netcdf file that includes the unit of the data or the long name of a variable. An Xarray dataset is basically different data arrays that are together, that are bundled together. They potentially share the same coordinates, but that's not always true. So for getting started and better understanding the concepts of data structure and data array, I had this tutorial. This is like one of the more used tutorial data set. So first, let's load this tutorial data set. And here, we just loaded the tutorial data set, and this is the wrapper method for this shows the representation of the data set. So we opened up this data set and we checked out the representation of the data set. And you can see there are variables, coordinate dimensions, attributes. You can click on them. We can extract the data array from it. Data array is the variable with the attached metadata. So here we are extracting the data array. And you can see it has, again, some coordinates, some attributes, the indexes, and the data attached to it is also visible here. We can check out, for example, if we want to access the dimensions, we can check out the dimensions. We can also check out the coordinates of this data array using the da.coords or the data array.coords. I'm going through this part fast so that I can compensate for the delayed start. And you can see the attributes of this dataset also here. It's a dictionary that includes all the metadata for this data array. And with the dictionary, as you know, we can provide the key and also access the value of that dictionary. So here, the long name, you see what the long name of that variable is. So, okay, so this was a tutorial dataset, and usually, at least in my case, working with a tutorial dataset, they always work, and then real dataset, when you want to load them, they never work. So, for this tutorial, what I wanted to do was working with a real, Lens 2 dataset, which is something that I've noticed a lot of students and postdocs ask questions about, like how work with Lens 2 dataset. It's pretty popular at NCAR. So let's get started on using another dataset or like a real NCAR widely used dataset. So for that, we need to read in some netcdf file, and that's a common workflow for data analysis. scientific data analysis, at least in Earth System Science, is that we have like some netcdf file or some Xarray files or HDF files, and we have to open them up and then do some data analysis. And Xarray provides, Xarray has this open dataset and open multiple files dataset or OpenMF dataset, and it has support for netcdf, Xarray, and HDF5, and it also has support for other formats, for example, grid, but it requires some additional packages to be installed. For this tutorial, we are mostly focused on netcdf. And if you are familiar with netcdf, you know that netcdf, like it has some data and then there are some metadata, like there is metadata attached to it. And Xarray is Xarray dataset that we learned earlier is built upon the netcdf data model, really. The dataset, Xarray's dataset, it's technically an in-memory representation of a netcdf file. So that makes working with Xarray dataset very easy. And that's like very intuitive because it translates very well from netcdf to Xarray dataset. So let's get started with reading the netcdf files. And as I said earlier, there's open dataset, which open one file, and you can open multiple files with OpenMF dataset. OpenMF dataset use dask delay and open the data using dask arrays under the hood, which is fantastic. But for this tutorial, for the first part of the tutorial, since we are mostly focused on Xarray, let's open one file first and then get started with that. So let me make this bigger. That works. No, it doesn't work. So anyhow, so I provided some link here, some links that has the information, more information about the CESM2 large ensemble dataset, the Lens2 dataset. And for this tutorial, we are of course only loading a subset of the data. Really, if you want to load the dataset, the whole dataset, it's going to require dask and a lot more resources, like scaling it up to many nodes to be able to load the whole dataset in. So there is this function called getData. There's this helper script called getData.sh. So if you are running this tutorial sometime and then in the future, and you don't have access to Casper, you can still get the data on your local machine. Or for this tutorial, you can also run it through Binder as well. So you can get the data through Binder. So you can run the get data, and it will get the data for you and stage it in the correct directory. Of course, I ran this before, and that's why it says it already exists. It creates this data directory for you. So here I just list all the files that are available in that directory, in the data directory. And these are the files that I just downloaded. And then we can use Xarray open dataset to open up one file. So with Xarray open dataset to open one file, you have to provide the path to the file. So here we had a list of files, and I wanted the first file to open one file. So I just did this and then opened up this file. Okay, let's look at the representation of the dataset, Xarray dataset here. So again, we can see there are coordinates, variables, and attributes and dimensions attached to it. And for this tutorial, we are looking at the near surface air temperature. It has time, latitude, longitude. So please feel free to explore the dataset. Here I'm loading that variable. It's called tref. It's a temperature at reference height. So I loaded that up with a data array, using a data array. And then I'm looking at the dimensions and coordinates. And I am going through this part intentionally fast again, because I want to avoid going into details on these the introductory parts. So you can also access the data on the underlying data, and you can use data to see what's the underlying data, because so far what we have seen is the coordinates in the indices or dimension and everything, but we haven't seen the data. So how to access the data? You can use the dot data to see what's the data in this variable. So I can run it and it will give me a NumPy array that includes the data that's in the data array. And that will come in very handy once we learn about Xarray and task array and how they work together. So okay, that was fun. We have this containerized data structure that has the netcdf, like all the netcdf data and the netcdf metadata. But how can that help? Why is Xarray so powerful? And one reason for that is that Xarray indexing is very easy. It's very easy to work with Xarray data structure with the different Xarray indexing methods. So I'll go through each one of these different Xarray indexing methods shortly. So to summarize it, there is like position-based indexing and label-based indexing. So I'll go through them one by one. So back then when I was in grad school, I actually used MATLAB, and it was like 2014, and I had to work with like netcdf files. And back then I had to remember all the different dimensions that was attached, the order of the dimensions of the data, or the data structures that I had. So here we can use the same syntax as NumPy or MATLAB to, it's called position-based indexing, to check out, to find a particular point. So here, for example, I'm finding this particular point using the NumPy-based indexing. It's very similar to MATLAB. But this requires, let me show you, this requires you to remember the order of the dimensions. So for example, is this dimension the latitude or is this dimension the latitude? Which one was the latitude? And that's very error prone for data analysis. Oftentimes in my grad school, I had like this post-it note on like next to my screen that had the order of the dimensions. I had to like remember them, and it was making working with data set hard. So to address this issue, Xarray offers the position-based indexing using dimension names. So we can use dimension names directly to find the data. So for example, here, and it's using the ICEL method. So for example, here I want to find, I want to make a plot of the first time step of my data array. The only thing I have to do is provide it the dimension name or the dimension name, and I say like, okay, I want the first time step. So that will give me the plot. That's very easy. That's very nice. Slicing also works similarly using slice. So here I say, okay, create a plot for me at this particular index of latitude and longitude, and slice the first 20 first time step. This is zero-based indexing. The first 21 in time steps. So here it makes the plot for me, and I'll talk more about this plot shortly too. But I just wanted to show you how the indexing works using ICEL. Okay, this is really nice, but this is still requires you to know like which. So for example, let's see, I want to create this plot at Mesa Lab from the Mesa Lab location. This requires me to understand like what indexes corresponds to the Mesa Lab coordinates, like how to do that. And in MATLAB, we have like some helpful functions that I remember I wrote for finding the nearest lat and long. So here, Xarray really makes it easy because it provides label-based indexing using dimension. So far we talked about position-based indexing. Now it's label-based indexing, and that's using the cell method. So that this makes it really easy to find. You don't really need to do much. You can find like you can make the plot, for example, at particular latitude or longitude. Here I am giving an example. Okay, so let's create a plot at this particular data line, and this is how it looks like. Similarly, slicing works the same way. Yeah, so that's great. But sometimes the particular Latin line that you are looking for does not exist in the coordinates. And if you, for example, I mentioned the Latin line of Ankara Mesa Lab. So if I give the exact Latin line of this location, it will fail for me because that particular coordinate does not exist in the coordinates of the data array. So to address that, you can use the method and the tolerance parameters when you're using the cell method to provide to find the nearest point, or there are different methods here, but to find the nearest point basically that has that's to your location. So for example, here I am using method nearest, and there are different methods. You can use the backfill and the padding, but and I try to explain them here how they're different. But you can use the method, and also you can give it a tolerance argument and provide some value for that tolerance. So I want the nearest point, and this is the tolerance that I accept for that nearest point. So if I ran this without this method, it will fail. It doesn't work. But if I run it, so you can see it doesn't work because it says that the values that particular Latin line does not exist in the coordinates. But when I use the method nearest, it finds the nearest point for me to this particular Latin line. That's really helpful, and that's really nice. Another nice thing about the Xarray indexing, very powerful, is the date time indexing, especially for time series data sets. Easy date time indexing is key, I think. And Xarray provides that. You can give it a certain date, and it will plot that date for you. So here I'm providing like this January 1st, and select that, or like find that point. And by default, if there were like right now, there is only one point associated with this selection. But if there were multiple points associated with that selection, Xarray would have found it. So for example, here I'm saying to find all the points for me, and that is in 2024. And this shows, because the data was like showing monthly means. So this shows 12 different data points that were selected. So this is very helpful to find the data for a particular year or particular month. Okay, that's really nice. You can also, it supports slicing as well. You can do slicing similarly. Here I'm selecting all the points between these two particular dates, and it works again. It's very similarly. Okay, let's see. Xarray also support, it's called fancy indexing, and it's a pandas concept. Pandas data frames also support that. And the fancy indexing, what it provides you is using the DT accessor, the datetime accessor. You can easily select like a criteria that to select a point or to slice that like data for you. So it provides really easy indexing using fancy indexing. So I put an example here that will explain it. Here I am selecting all the points in my data set for the month of July, and you can see how I'm using the DT accessor and this month, and then I'll say, okay, so month is equal to 7, which is like July. So this will provide and find all the points that are for July in the different years, and then add them together, create this data array that includes all those points. That's very, very powerful. And all of these indexing that I said at the top, they were on, like the examples in the above were mostly like data arrays, but the same thing, it works with data set as well, and it conserves the metadata when we are doing indexing using the different types of indexing I mentioned. So that is one of the reasons that Xarray is so popular. Oftentimes, if you like do some analysis and come back to it a year later or 6 months later, it would be really easy to find out what has been done in that notebook. And you don't have to remember the dimensions and the orders and if that was correct or not. So it's really easy to work with NetCDF files using Xarray. Okay, so let's go to do some different computations with Xarray to see how it works. Xarray supports, Xarray dataset supports basic arithmetics. So basic arithmetic, basic maths, they all work with Xarray objects. Here, just a very simple example, the data that I had was in Kelvin, so I can easily calculate and convert it to Celsius. So that's very easy, that's very convenient, and we can do different things. There are different ways of doing aggregation or reductions with Xarray. So Xarray supports several statistical functions such as mean, standard deviation, variance, minimum, maximum. So here I am calculating the mean or the average of my data array over time, and I'm plotting it, and this is the plot, the output plot. And you can see it's like relatively easy to use all the different, like the mean, the average, or the standard deviation, or the minimum like temperature for like here, for example, I am finding the standard deviation at every time step. So here provides it. So it's really easy to work with the Xarray dataset. Sometimes we require more sophisticated analysis, and that's also possible to do. Xarray has some very useful high-level objects that let you do some common computations. So for example, we have group by, we have resample, rolling, Corson, and weighted, and I'll explain all of them with examples shortly. So here, this is an example of group by. And group by, this is again very similar to pandas, if you're familiar with pandas. It allows you to group data arrays and data set by one or more dimensions, multiple dimensions. So here I'm grouping my data array by month and calculating the average. And then creating a plot here, this was the coordinates of Mesa Lab, and then creating plot at that point. So that's how it would look like. And since we grouped it by month and calculated the mean, this means that this is the average temperature from the data set that we have for each month. Similarly, for example, we can calculate the seasonal mean here using the time.season, and above I was using time.month. If, for example, I was using, it was like daily or hourly, I could have used like day or hour. And here I'm showing the data array, the seasonal mean data array. You can plot it here easily. So this is the seasonal mean at the different seasons. And the order for this was not correct. So you can create, like you can fix the order for this using the cell method that we learned just in the previous section, and select the seasons in the order that we want. So here we do that, and voila, that's like showing the seasonal means based on the orders that we want. And this is very powerful. It makes really long data analysis that was done previously, like with MATLAB or NumPy or any other packages that were like very long into 5 or 2 or 3 lines of code. So it's it's really easy to create sophisticated plots and do sophisticated analysis with Xarray. You like one line or two lines or multiple lines. So another one of the high-level computations that are available with Xarray dataset and Xarray data arrays is resampling. And resampling is a method for changing the frequency or downsampling of time series dataset. And resample with Xarray only works on the time index. It doesn't work on the other dimensions. And so you can use resample. For example, here I'm resampling my data. I had monthly data, and I want to change the frequency to every 6 months. So here I'm using resample. I give it the 6ME, and previously the syntax was like 6M. But if I give it that, it says that future warning M is deprecated. So that's why I was using 6ME. I didn't know about that deprecation. So yeah, so you can give it the resample and the frequency that you want, and then calculate the mean. And this will resample to 6 months. And you can see how the time dimension changed. So the output data array has a different dimension. It's like smaller than the original data array. And this is important because some of these high-level computations to provide the output data array will be the same size, but with resampling, it's like smaller. It's just the points that we or the size of the resample data. Another good and very useful high-level computation is weighted. So weighted array reduction give the users capability to do any aggregations while applying specific weight to each point. And this would be useful if you want to add a weight, for example, like have like different weights for different points in the world, and then to calculate your mean using those weights. It's very easy, and it supports again mean, sum, standard deviation, the variance, and the quantile. So here is a very like it's a small example of weighted, but it has lots and lots of use. You can do lots of useful things with weighted. So here I am calculating this weights. I am creating this weights array. It's a cosine of my latitude, and the reason I'm doing that is that because our data using rectangular grid, the latitude is proportional to the grid cell area, so that's why I'm doing that. And if I plot this weights, and this weights, I'm using NumPy to create it, so it's a NumPy array. If I plot this weight, let's see, you can see how it looks like. So it gives more weight to latitudes that are near equator and less weight to the poles. And now let's calculate the weighted means using the weighted that I mentioned above. So what I'm doing here is that tref underscore C, that was the temperature in the Celsius unit. I am giving it weighted and then giving it the weights. And then I'm saying that please calculate the mean for like using the lat and line dimension. So here I am plotting it to show how it's different from the original array. So you can see it's the red is the weighted mean and the blue is unweighted. And you can see the blue is much lower because it has, because our weighted mean had a lot more weight on the equators and less weight on the poles, and that was expected. So that's why we have like higher values for the weighted means here. Again, a simple example, but it can be used for a lot of, for example, flux calculations, different types of calculation that depends on the area of the cell. So it's very useful. Rolling is another high-level computation that's available with Xarray. So you can use rolling to perform any types of computation or aggregation using a rolling window. And remember that I mentioned with resample, it changes the size of the array, but with rolling, it doesn't change the length of the array. It's a moving window and it applies it at each point. And I can show it with you, I can show it to you with this small example. So here I am calculating the rolling mean. I'm giving it 6, so it's a rolling mean using a 6 months window, and I am centering the window center through. I could have done it without this providing this argument. And then after I do it, I just printed out the shape of the original and the shape of the rolling mean to show how they are identical. See that? Now we can create a plot for it. And you can see when I applied the 6 months rolling, it reduced the variations that I have. So it's very, very useful if you want to look at long-term trends. For example, for climate data analysis, we want to smooth short-term trends and focus more on longer-term trends. And rolling window and rolling is very, very helpful for that to smooth out any short-term fluctuation. And hopefully this example showed it. Another high-level computation available with Xarray is Corsen, and Corsen is also very powerful. It's very similar to resample, but resample, if you remember, I mentioned it only applies to time dimension, and Corsen applies to different dimension. You can apply to different dimensions. There are some minor differences between the two of them. So let's take a look at Corsen with an example. Here I am taking a block mean, or I'm trying to Corsen the data set, taking a block mean for every 5 latitude and longitude, or like every 10 latitude and longitude, and plotting it just to show how it's different from the original data. So yeah, here you can see how it's now more like a coarser resolution. And to just compare it with the original data, you can see how it was higher resolution, and now we sent it to lower resolution. So very useful for some types of calculation, and it's powerful because you can apply it to different dimensions, while resample only applied to time dimension. So far we created the plots. We created some plots to show. The plots was the easiest way to show how you can create a plot, like easily create a plot with data set and data arrays. But there are more like advanced syntaxes that you can use with the dot plot. So here, for example, I am applying it. You remember, like we calculated the seasonal mean. So if I apply this argument, it wraps. It's like before it was like all like 4 of them in one row, and now it uses 2 different columns and wrap it around 2 different columns, and looks like this. Another example is using contour. So if we want to create a contour, we can do that. And here we added the levels and we added a color bar. So there are different arguments for this plot method. Please feel free to check it out using the Xarray guide. It's very detailed. There are many different things that can be used, and it's inheriting and it's using matplotlib under the hood. So let's look at another example. Like so far, these were like contours. You can do like different line plots. And so this was the seasonal means. Now I'm creating a line plot for it, and I'm giving it like the hue for it represents each season, and I'm giving it like an x-axis or y-axis. You can specify that. So just a few examples. There are a lot more things that you can do, and a lot more fancier plots that you can create with Xarray. So that's like very easy to do. Okay, let's see if I compensated for the time for the delay start thing. Not yet. So I still have to go through things fast. I'm sorry. So let's see. This is more on an advanced topic, but it's it's necessary for you to understand how Xarray handles some of the computations behind the scene. And two different important concepts on the computations with Xarray is broadcasting and alignment. So broadcasting, just in simple words, is that adjusting the two arrays to the same shape, so we can do, for example, basic arithmetics with them. So if we want to add two arrays that are different shapes, we can do that with Xarray. Xarray is doing it under the hood using broadcasting. So it's very, very helpful. Here I created a small data array. Here it has the space, it only has the space coordinates, and it's like it has like 3 data points. It's like my array 1, and the shape for it is, here it is. So there are only 3 data points on it, and it has only 1 dimension, but that dimension is space. Now the second array it's very similar. It has 4 data points, and the dimension of it has only the dimension time. So if I add these two together, let's add these two together, or like subtract these two from each other, and look at the data, the output now is 2D array. So those two above were 2 1D arrays, and now the output is a 2D array. And how that happens is that Xarray broadcasted each one of these arrays, so that like this one only had the space coordinates, this one has space dimension, this one had time dimension. So Xarray broadcasted these two, so each one of them is a 2D array, and then calculated the X. And you can see the output is an array 3.4. And maybe this figure explains it better. So here, what happened was, it's like one had like only this dimension, the other one has like this dimension. Xarray broadcasted each one of them to a 2D array, and then when we add them, or when we do like different computations with them, it's like the output is a 2D array. Okay, and here I looked at the data to see how it looks like, and we can go through, like I can explain this further if it's required, but I'm gonna the next method, which is the alignment. But please let me know. We can like answer questions during the office hours or at the end of the session, and have more questions on the broadcast. For example, here I explicitly like use the broadcast to show how the dimension of each one of these two changed. Let's move to alignment. And alignment is the second concept that is important when working with Xarray data arrays. And alignment, again, in simple terms, is putting data on the same grid. So if we have, for example, 2 different 2D data set that are not on the same grid, it puts it on the same grid and fill it out using different fill methods. And the output will be basically aligned so that it will include all these points and all of these points. And I can show it with an example. So remember, we had that temperature data array from the Lens2 data set. So I can select the points for mid latitudes here using slice, and this is, I'm just like showing it for 1 point, but technically you can show it for any number of points. For the sake of plotting, I selected only 1 month. But here I selected the data only for mid latitudes and selected the data for high latitudes, created these two Tref mid and Tref high. And if you look at the shape of these two, one has only 48 latitude points, the other one has 16 latitude points. But if we add these two together, and let's do that, or let's use xr.align. So if we use xr.align and we add like different join methods, we can use different join methods. Here I'm using from outer, and plot it, it shows the alignment concept perfectly. So here is the output. You can see what happens here. So I did the alignment, and I calculate the output is like one is the aligned data array. It's like the mid-latitude aligned data array. This one is the high-latitude data array. And I calculated these two using Xarray.align. And then I plotted the first one, the mid-latitudes, and you can see the output, the dimension of this output matches, it includes all those points for the high latitudes, but it masked it with nans. So now the two of them are aligned with each other and the size of them are the same size. And this makes, this will make sure that, for example, I have two data sets that have the same dimensions, but they are covering different parts of the world. And I want to do some additions, or I want to create an output cell that includes all those points. I can use this alignment concept to do such things perfectly. So this is very, very powerful, especially like if you have like regional outputs and you want to look more at the global like overview of things. Now going to the next concept, and I'm sorry for again going through these fast. If you have any questions, please feel free to ask them during the office hour. I would be happy to explain some of these concepts and use cases for these concepts further. So another very powerful feature of Xarray is the Boolean indexing or masking. And for this tutorial, I only used, I'm only showing how to use var, but we can also use isin, and that's another way that like Boolean indexing works. So Boolean indexing, it's a, I don't know, if you don't know about the Boolean indexing, it's a way to filter out your data or your variable based on a specific condition. So if you provide that condition and you want to mask your variable based on that specific condition, you can use that. And the Boolean mask that you'll provide is a binary array. It has like some true falses or some flags that will filter the data based on that specific, and will filter that data based on that specific mask. So here I am showing an example using var. So how masking with var works. So what I'm doing here is that I am providing, I'm selecting all the points for July. And remember, this was the fancy indexing using DT, similar to pandas. And I'm calculating the mean or average for month of July from all years. So let's do that. And now, if I plot this, let me plot this. It has, this is July, so it should be warm overall, but it has like some cold points. And I, for example, say I want to mask out all those cold points, all the temperature below 0. I can easily do that using var. So I'll say mask the data for me where the temperature is above 0. So, and then here I'm showing how the shape remains the same. So it's doing broadcasting, the concept that we learned above. The shape is the same, but it has like, now it has like some nan values. And I can do Xarray, I can use var and give it like a fill value. So I can say, for example, fill it out with 0. And actually I'm showing it in the next step. So here again, I'm showing how you can provide a value, like fill all the temperatures below 0 with 0. I want to, like, those points are not important for me, for example. We can do that. And again, I mentioned like the shape remains the same. That means that the var is performing broadcasting, and that's why the data shape remains intact. And now let's make the plots for all the 3 of them side by side to show how it worked. So this one is the unmasked data, the averages, July averages, unmasked data. Here we mask it without providing any fill values. It's like all nans here. And And here is the field array or the mask array with like a field value of 0. So all those points have like show 0. This is particularly helpful if you have some missing value that you want to fill in with like some certain placeholders. That would be a perfect solution for something for problems like that. Okay, let's go to the next concept. So far, what we worked with was Xarray data arrays that were using NumPy under the hood. And we showed that when we were using here, we show it, href the data. I remember that for accessing the data. This was if I do a type, so show me the type of the underlying data, and you can see it's a NumPy array. But Xarray, one of the most powerful things with Xarray is that it can easily be extended to use a lot more different packages. So we can, for example, use dask arrays under the hood. And dask arrays are perfect for some of the analysis because it uses lazy evaluation, which we'll talk more about in the next section. It also supports different types of array, and I know there are support for more types of arrays coming. So it supports sparse arrays. It supports Kupai array, which enable GPU computing using Xarray dataset, and you can check out by Xarray. There is a new tutorial that we created for that Kupai Xarray recently. There is this Pint Xarray package which use Pint arrays under the hood. And what Pint is a unit-aware array, and that would make things much easier for doing unit conversions. It's really, really easy to do complex unit conversions using Pint arrays. So please feel free to check that out anytime. Okay, so remember on the top, I opened only one file from the number of files that were available in that directory because I wanted to show everything using NumPy. You can easily use open multiple files dataset, which opens up multiple files using Daskelate and Dask arrays. And I just wanted to show how Xarray wraps Dask arrays under the hood. So here, again, like I'm showing, so far everything was NumPy array. But let's open up like all the files and that were available. Remember, there were multiple files. There were like 9 files in total available in that directory. So let's open all those files and then concatenate them over the time dimension, and we can like combine them. There are different methods for combining them, and there are different engines that are available for Xarray here. We just try to be explicit. It auto detects the engine that's required most of the time. And I'm not going to go through like all the parameters here, but I just wanted to show how it uses Xarray. It uses Dask arrays under the hood. So here I opened up all the data using the open multiple file data set, and the output is a data set. And then I created a data array from it here. This is a data array of this temperature at reference height. So let's run this cell and see what happens. And we are looking at the representation of this reference height. So you can see, okay, so this looks exactly identical with before. The only difference is that now you can see it's using Dask array here, and it has like some information regarding Dask arrays. And we can even type that, print the type of that. You can see this is our data array, and I'm accessing the data underneath it, and I want to see what's the type of that. And if I print that out, it shows that it's using Dask arrays. So from like user's perspective, this doesn't look any different from their syntax when they were using NumPy versus like task arrays, but it's like so powerful that it works with like different types of arrays. And that's very, very powerful feature. For example, with CuPy also it's like all hidden from the user side that it's using GPUs. It's like loading data on the GPUs, but it's from the user perspective that's hidden, but it's doing that under the hood. Another concept that is very helpful for different types of like computation, more advanced computations and more advanced workflows is using apply ufunc. So apply ufunc, and if you're not familiar with it, you can create a function that does like that calculates something. So for example, our example here calculates saturation vapor pressure, and it's like a very complicated. You can see it's like a very complicated equation, and you can use apply ufunc with Xarray dataset and data arrays, both using task arrays and NumPy arrays to apply this function on the whole array. So here, this example, let's run this. This is our function. The input of this function is NumPy array, and the output of the function is also NumPy array, where it can be different types of arrays. And if I apply this use Xarray apply ufunc or on vectors function, you can see it calculates the saturation pressure for me using this function. And if I will take a look at it, yeah, the output of it, that's like how, like that's the output of it. So it's very, very helpful if you want to find out some diagnostic values that requires a lot more computation, and especially very useful when we are loading, when we are using task arrays under the hood. And we gave a very, very detailed apply ufunc tutorial at SciPy, so please feel free to check that out. I didn't include all these here because that was out of the scope of this presentation, but please feel free to check that out. It has lots of good examples on apply ufunc. And overall, what we learned in this tutorial was the basics of Xarray dataset, data arrays, how indexing works, different types of indexing that was available, position-based and label-based, how we can read and write data with Xarray from netcdf, and also we can do it with different types like HDF5 or GRIB or different types of files. And we did some basic and advanced computations with Xarray. We understood broadcasting and alignment. These two concepts were very important for some of the Xarray computations. And then we learned about apply ufunc. We also learned about like more advanced Boolean indexing using PAIR. And yeah, please feel free to reach out if you have any questions, if there is anything in this tutorial that you need more help with, or like you want to discuss more details, I would be happy to answer any questions. And feel free to go over this tutorial. It's available in the GitHub repository, and the directions for running through these notebooks all are available in the GitHub repository in the README page. So yeah,